Continuing with the geometry concepts, we have to cover surface area and volume. These are three-dimensional figures. Surface area is the area that it would take to cover a three-dimensional figure. If you just picture how much wrapping paper it would take to cover a box, that's what we're talking about here. Surface area is measured in square units. Area is always measured in square units. Volume is how much it would take to fill up that box. So if you think about packing peanuts or something like that, volume is a three-dimensional measurement, so it is measured in cubic units, cube being to the third power. You have a formula sheet that gives you a picture of these things, and it gives you the formulas. The pictures kind of help a little bit to settle what these measurements mean in your mind, but we really want to just follow the formulas or we'll kind of get lost. If I have a box, I have three measurements for a box: length, width, and height according to the formula. So here are my three measurements, and instead of using the word height, they use the word deep. Same thing. Length is going to be equal to 60. Width is going to be equal to 50. And my height is the 2.5 inches. Now the formula for surface area is a big long one. It's 2 times length times the width plus the length times the height plus the width times the height. If I have those measurements listed with the values next to them, it makes it fairly easy to plug into the formula. Because everywhere there's an L, I'm going to put a 60. And the W's are all 50s. Length is 60, height is 2.5. Width is 50, height is 2.5. Now the groovy thing about a graphing calculator is I can type in that big long sentence exactly the way it looks. Make sure you're putting the right operations in there. It's 60 times 50, then a plus sign, and 60 times 2.5 and a plus sign, 50 times 2.5 and a plus sign. Make sure you put parentheses around that whole thing. When you do, I end up with a surface area of 6,550, and this is square inches. Volume is how much it would take to fill up the box. It kind of makes up for the surface area formula because it's nice and short. The fact that those three letters are bumped up against each other just means times. So if I know my three numbers, I just multiply them together. 50 times 60 times 2.5. Multiply them together, that gives me 7,500. And this is inches times inches times inches, which makes inches to the third power, or cubic inches. Now the second one, we want to do the formula twice. I've got a tree trunk, and we're going to assume it makes the shape of a right circular cylinder. So we're ignoring any little bumps and stuff. Is there more wood in a tree that's 40 feet high and has a radius of 2.1, or in a tree that's 30 foot high with a radius of 2.4? Well, we want to work our formulas. If I'm wanting to know how much wood is in a tree, I'm looking for volume. The volume formula is pi times r squared times h. In my first problem, my height is 40. My radius is 2.1. And we're going to use 3.14 for pi. So if I want to find out how much wood is in my first tree, the volume is 3.14. Now I'm going to multiply that times the radius, and I want to square the radius. So I should do 2.1 in parentheses with a square on the outside, and then that is times my height, which is 40. You want to be very careful when you type that into the calculator. It's best to do it all in one step so you don't go outside of the order of operations. You should be able to type that in exactly the way it looks, and we would end up with an answer of 533.896, and this is cubic feet. I didn't round it off because we're going to compare with another answer. So we don't want to round this off and end up with two answers that are exactly the same, which weren't really the same. My second tree has a height of 30 and a radius of 2.4. Again, for the volume formula, I'm going to use 3.14 for pi. I want 2.4, my radius, to get squared, and then I'm going to multiply that by 30. If I do, I end up with a volume of wood in my second tree trunk of 542.592, and again that's cubic feet. So the question was, which tree trunk has more wood? The 30-foot one. The shorter one with the bigger radius has more wood. Now I want to find the volume and the surface area of a sphere with a radius of 4. Now because the sphere is just a three-dimensional circle, it's a ball, the only measurement we have is the radius. The formula to find the volume is 4/3 pi r cubed. Again, find it on your formula sheet. You're not going to be expected to memorize this. When I plug in my numbers, on my calculator it's always best to put my 4/3 in parentheses. I'm going to multiply that by 3.14 for pi. And then I'm going to multiply that by my radius cubed. Now I write it as just 4 in parentheses cubed. On my calculator, this part, I would do my 4 in parentheses, use my caret with an exponent of 3. Now if I multiply all those numbers together, my volume turns out to be 267.95, and that's cubic inches because it's volume. If I want to find the surface area has a formula of 4 pi r squared. 4 is part of the formula, pi is 3.14, r just happens to also be 4, and I want to square the 4. So this is 200.96 square inches. I have a cube, and it tells me my side measures a 1/2 meter. I only need one measurement because every way I go on a cube, all the sides measure the same. The volume of a cube is just whatever the length of a side is, cubed. Well, if my side is 1/2 meters long, 1/2 cubed is 1/8, and my units are cubic meters. I want to do the surface area of a cube, that is 6 times L squared. 6 times 1/2 with a square on it. That turns out to be 1.5 square meters.